Hello, I'm Joe from Robertson Heating Supply. Today I would like to go over the different styles of replaceable filters, the different Merv ratings of those filters, and how the different Merv ratings perform in the system. I will be going over 3 of the most popular styles of filters: fiberglass, pleated, and media style filters. First, I would like to discuss what Merv stands for, which is Minimum Efficiency Reporting Value. The value ranges from 1 through 20, and the higher the Merv rating, the smaller the particle the filter will capture. Merv ratings of 1 through 4 filter down particle sizes of 10 microns. Pollen, dust mites, carpet fibers, for example. Applications include residential, window ACs, and commercial. Merv ratings of 5 through 8 filter down to particle sizes 3 through 10 microns, which includes everything I mentioned prior, plus mold, spores, cement dust. Applications include residential, commercial, paint booths. Merv ratings of 9 through 12 filter down to particle sizes 1 through 3 microns, which includes everything I mentioned prior, plus lead dust, humidifier, dust, and coal dust. Applications include high-end residential, commercial, and hospital labs. Merv ratings 13 through 16 filter down to particle sizes of 0.3 to 1 micron. Includes everything I mentioned before, plus bacteria, tobacco smoke, and copier toner. Applications include hospital patient care, general surgery, and smoking areas. Merv ratings of 17 through 20 filter down to particle sizes less than 0.3 microns, which includes everything I mentioned before, plus viruses, carbon dust, and combustion smoke. Now, I have a bunch of filters right here that I brought in. These are all good, high quality filters. So I bring in a bunch of them that I can use and show you the different effects that the filter has depending on Merv rating with a static pressure test. So I brought in a standard fiberglass filter, Merv 7, Merv 8, Merv 10, 11, 13, and a carbon filter. Now these filters come in different types, like this pleated filter that is actually 2 inches in size, all the way up to our media style filters is what most people commonly call them. Now this filter is kind of a combination media filter, but it actually has a gasket on it. So there's a gasket on the filter top and bottom, and then the frame that it fits into on the cabinet on the back has a piece of insulation on the back and on the door front to seal it 360 degrees around it. The next style filter is an expandable media filter, and the expandable filters are what some people call accordion filters. So they actually go into a plastic housing or a metal frame, and there's combs that separate these and keep these pleats equally distanced apart to capture dust to space out the filter correctly. These are nice because the box fits in a very, very small frame. You get the filtering of something like this, but in a package of this size. So it's easily to keep on trucks and service, and it just takes up less space. The next, if you don't want to use this style, you can use this style right here, which is an accordion filter that has rails built into it. So you don't have to use the combs to insert them in there. This just slides on 2 rails and goes right into the filter. So a nice upgrade for that old style filter. And once again, in a small package for easily to go on trucks. So I'd like to move on to our training cart here. I have the system set up so we can test total external static pressure on the system. So I'm going to be using these 14 by 20 by 1 inch filters. They have different Merv ratings on there. So here we got our manometer all set up. So we have our supply positive pressure underneath the coil, and then we have our negative pressure sensor down here in the return cabinet. So we're going to turn on our manometer and make sure it's 0 out before we start the test. Then I'm going to give the unit a call for cooling, and you can see it's all zeroed out. and we're going to get a baseline number here. So we're getting a baseline number about 0.18 total external static pressure. That's with no filter on it. So the first filter we're going to try is this fiberglass filter. So it's our standard filter that most people use in the system. We'll give it a few seconds, and you can see the effect of putting in the filter. So we have went from 0.18 up to about 0.25 on average. And that's just a basic fiberglass filter. So let's go to a little bit higher Merv rated filter. This is a Merv 7 filter. So you can see our static pressure has climbed, and we're almost to 0.3 inches of water, 0.39 inches of water column for our total ESP. So the next filter that I have is a Merv 8 filter. So these are all pleated. So you can see our static pressure is hovering right around 0.37 approximately for that Merv 8 filter. So we'll move up into a little bit higher Merv rated filter, which is our Merv 10 filter. The one thing that's important to point out on these filters is you really want to make sure that you put in the filter properly, because there is supporting mesh that holds this filter from unraveling, and then different pieces of cardboard that keeps that. Some filters don't have this supporting cardboard. If you put it in backwards, that filter will unravel, and then the customer will have a difficult time pulling it out in the future. So that's very important. Also, there's usually an airflow indicator on the filter, like this. And it's important to put the filter back in, if you check it, to put the filter back in at that arrow's pointing in the right direction. If you flip it around, you could release the dust particles off of the filter that you attracted to the one side of the filter, and then release them back into the furnace. So it looks like our static has moved up to 0.39 for this filter. So we moved from the Merv 10, and we will go up to the Merv 11 filter and see how we do. So you can see once again, as we move up into the Merv ratings, we are now in Merv 11. Our static has moved up to about 0.44 on average. And our last filter, the Merv rated filter, is our Merv 13. So this will be our most restrictive filter in this system setup. And you can see we get up to about 0.55 inches of water column with that filter. Last but not least, we have a carbon filter, which is our last filter. Carbon filters are useful in reducing odors in the space. So you can see that only puts out about 0.36. So not too bad. So I took all the readings that we got from our blower performance test of all the filters, and I wrote down our total ESP for all the filters. No filter as our baseline, fiberglass filter, Merv 7 through 13, and our carbon filter last. Why this is so important is, on a standard furnace, they have a blower performance chart similar to this one right here. Had that furnace been, let's say, this 95% efficient 70,000 BTU 3-ton drive furnace here, on, let's say, medium speed is where we had it selected. If we had our standard filter, which is a 0.25 ESP, total external static pressure, it would have been right between 1180 and 1130 per CFM on that test. Now, had we put in the Merv 13 filter, instead it would have been between these two numbers right here. So we have our 70,000 BTU 3-ton drive on medium speed. It would have been between these two, between 1055 and 1005. So in the neighborhood of 150 CFM drop. Sometimes that can get larger. Now, that doesn't mean these filters are bad because you have a higher Merv rating. You can increase the size of the filter. So if I really wanted to use this Merv 13 filter, this is only a 14 by 20 filter. Have I upsized this filter up to, let's say, a 16 by 25 filter, I might be able to get away with this filter and my static pressure will drop to a more reasonable number. It could be this filter is too small to use as a Merv 13, and by increasing it to a filter of this size, I get more surface area for that air to make its way through, even though the filter is more restricted. Or I could go to this style filter that has even more filter area that might have a lower static number. Most manufacturers will list their static numbers and have a chart that will tell you how many CFM that will move at a certain static pressure. So you can kind of do your homework on that. So that's why it's important to utilize that chart and your total ESP to figure out how well your performance is on your system. Thank you for watching our video today. I hope you enjoyed it. If you have any questions, please feel free to reach out to our engineering department at Robertson Heating Supply. You can reach us at 330-821-9180 and ask for the engineering department. Thank you.